Hello, hi, welcome. This is Ashwath from VIT. Hello, hi, welcome. This is Ashwath from VIT Chennai. I'm currently pursuing MTech Software Engineering Integrated course. So I'm here to explain you about message authentication in ISS. I know there are various topics like ransomware attack, cloud security, transmission control security. There are various type of security, various vast topics to be discussed in ISS. But I chose message authentication because it's the most simple and important one. I want my hi message to be delivered as hi to the receiver. I don't want my hi message to be modified into you're a stupid by the intruder, right? So message authentication is the most important part of cryptography. I need let's forget about videos. Let's forget about pictures. The basic text message which I'm sending, I want the receiver to receive the exact message which I intend to send, right? So let's go into the topic and see what we have here to learn about. So, as we discussed, this we are going to discuss about what is system security. So, a system security is about protecting computer systems, networks, and data from security threats. So, if I'm implementing a system, let's say I'm creating a payroll management system, I'm bringing its novelty, all the stuff. I'm having an excellent user interface. I'm having excellent functionalities. I'm having great investor, and I satisfy all the requirements. But if I don't have the security, if I don't have the ways to protect my software from the intruders, then I'm zero, right? Anybody can access my software. I have to insist, I have to be more careful when I'm implementing the security measures to my system, to my application, to my software. Am I right? So yes, system security is nothing but using using a set of algorithms, a set of procedures, set of rules, or set of um, resources to imply security, to make sure no one hacks my security, no one hacks my system. The main objective of system security is to ensure confidentiality, integrity, and availability of information resources within a system or a network. You can also say that it is put in place to prevent unauthorized access and malicious attacks. That's what I meant. That's what I mean about. I don't want anyone to access my software. I need my privacy. I'm giving to my client, man. I don't want anyone else to intrude in and take all the data. That results in a weak link, right? So I don't want that. So there are key aspects, or let's say these are the particular particular distinct points that we have to take in order to imply a effective system security. So access control, data encryption, firewalls, detection, and prevention systems, antivirus, patch management, security policies, and procedures, security awareness, backup and disaster recovery. So I'll say what about access control is? Access control is nothing. I mean, I'm deciding who is going to access my software. I'm going to decide who will operate this particular system, this particular part of the system. I will I will decide who will be working on my system. Data encryption is nothing but, let's say I have a high message and I have encrypted the data into, or transferred the data into HI data into E4321Z. So this is an encrypted message, and I have the key to decrypt it. So I'll just encrypt a message into this form. That is data encryption. Firewalls, it is to prevent the intruder to enter into my software. Intrusion detection and prevention system. So let's say the intruder is trying to hack my system. I need an alert system, right? I need someone to tell me that someone is trying to hack into your system. That is this. Antivirus. Antivirus, let's say my computer has been filled with ransomware. I need them. I need the worms. I need the bacteria. I need bad viruses to go away from my system. These antiviruses can be used in order to eradicate my virus present in my system. Patch management. Patch management. Um, it's an interesting one. It's it's kind of intelligent. Let's say I have a bug. Let's say um, let's say my pointer is not working here. I have clicked chat here. Let's say that the cursor is not moving, and I have debug. I need a patch management. I need a corrected code to work it. So same way, a security patch has been diagnosed, an area where the intruder can enter. So that has been diagnosed. I have to fill that gap, right? So that is called patch management. This does job of filling that area so that no one can enter. Security policies. So such as having strong firewalls. Again, security policy is nothing but all this but collective points. Backup and disaster recovery. Let's say all my systems have been corrupted. How quickly can I get back? Quickly can I retrieve that? That's the efficiency will be measured in backup and disaster recovery. Why do we need security? Ah, I told you, we need security to have a basic, efficient system or software or program or application, anything. You take anything, we need security. Without that, it's nothing. It has no value. If you want to buy a bat or a cricket bat, you need to keep it in a safe place. You can't just leave it in a pouring rain. You need security. You need a shell. You need a shelter, right? Same way. If you buy a laptop, you need to install an antivirus. Without that, your laptop won't function. I mean, it will function, but it has the higher probability of getting attacked by viruses, right? So we'll go to the main topic called message authentication. Before that, these are the type of threats, and message authentication is one among. Okay, I'll tell you why I chose message authentication in the next slide. Well, I'll tell you. So, type of threats: access control, data encryption, firewalls, intrusion detection, prevention system, antivirus. It's the same. The same. The disadvantages of the main key aspects of uh, system security as a type of threats. Anybody can gain my access control if I don't have the corrected firewalls, right? So it's just the same. We don't have to waste time here. We'll move on to message authentication. I'll tell you why I chose this. So everybody thinks in advanced level. I need my cloud to be secured. I need my uh, database management system to be secured. Man, you have to be thorough in sending a high message to receiver, and you have to make sure that is safe at first, right? You have to learn about that basic thing in order to imply in the bigger or larger scale. This is a very interesting topic. I don't know why why I'm insisting so much on this, because it gives me a uh, see, I'm a sports person, so I in sports generally we focus on the basics, and that builds the character. So message authentication is the basic implementation of cryptography. Is one of the basic implementation which has led to various technologies development, various innovations and stuff like that. So let's say it started from text message, pictures, videos. Now it has been it is flowing on. It is flowing on. So there is just so many other new inventive things, right? So let's stick on to the basics first. Data is prone to various attacks. One of these attacks includes message. message authentication. This threat arises when the user does not have any information about the originator of the message. Message authentication can be achieved using cryptographic methods, which further make use of keys. So, the usage of keys is nothing but I am the sender and you are the receiver. I'll have a key. I'll encrypt the data and I'll have a key. You will receive my encrypted text, also my key. You will have a key. So you will compare my key with your key. If those two keys are matched, then the received data is authenticated. I mean, you know that you received it from or an authenticated user, and you can also decrypt the encrypted data using the key. So that's the use of keys. It's a very basic term I have explained. I will go deep in coming slides. Message authentication is a security mechanism used to verify the integrity and authenticity of a message or data transmission. It ensures that the message has not been altered or tampered with during the transit and it originates from a trusted source. Message authentication is essential for protecting against unauthorized modifications, data tampering, and forgery in communication systems. See, there are two functionality levels we need to focus on. The first level creates the code that proves the message is real. Um, the message is real in the sense, is it a text message or not? Simple. We'll stick to very basic English. The first level creates the code that proves the message is real or not. Whether did he send a blank message or not, that's a basic level. Whereas the second level uses the code to check the message that has been tampered with. The second level of code works with a process of identifying the message has been tampered or not, whether it has been modified or not. That is the second level. So these are the two functionality levels. One, it checks if it's real. Second, it checks if it's tampered or not. So there are five basic methods to imply message authentication, right? There are five basic methods to imply message authentication. So one among them is cryptographic hash functions. So what is cryptographic hash functions? They are used to generate a unique code for a message to ensure that it has not been tampered during the transmission. It uses functions such as SHA-256. This you might not understand. I'll show you a diagram, then you will understand. So listen, there's an input Fox. A hash function has been performed. What happens is it encrypts it encrypts the data in some unreadable form, and not unreadable form, ununderstandable form, using a hash function. And this is the output. This is the red fox. This is the let's say fox is the plain text. Using the hash function, the output is DFDCD3454. There's no relation. This is three-letter word, and look at them. Three, six. It's a nine-letter. It's a nine-character word, right? There is no similarity between input and plain text and hash. This is the beauty of this. And another disadvantage is you can't decrypt. Maybe you can decrypt with brute force attack, but it's not all. It can't be done always. Only in certain circumstances, like a small word or frequently used words or sentences. So I'll read this now. Hash functions such as SHA-256, secure hash algorithm 256-bit, or MD5, message digest algorithm 5, are commonly used for message authentication. A hash function generates a fixed hash value from an input message of any size. The hash value uniquely represents the original message, and even a minor change in the message will result in a significantly different hash value. By comparing the received hash value with computed hash value, the receiver can verify the integrity of the message. So basically, my message, I if I have the plain text, I will decrypt using the hash function. That's it. I can't I can't, sorry, I'll encrypt I'll encrypt my plain text with hash function. That's it, done, job over. I can't decrypt it back. So that's why the cryptographic hash functions are one-way functions, meaning they are designed to be computationally infeasible to reverse or decrypt. I'm sorry. As a result, it is not possible to directly decrypt a cryptographic hash function to obtain an original input message or data. Moving on to the next one. Message authentication codes are used to generate a tag for a message that is verified by the receiver, ensure the message is authentic. Um, let's say uh, the sender sends a plain text with a tag, and the receiver has a tag. The receiver verifies the tag and gets to know that the received information is valid, or I received from this particular person. I know uh, who sent this message. I know where this message is coming from. That is a valid transformation of message. So message authentication codes are cryptographic constructs that use to secure a secret key to generate a tag for a message. The sender computes the MAC using the secret key and appends it to the message. The receiver verifies the authenticity of the message by recomputing the MAC using the same secret key, comparing it with the received MAC. If the computed MAC matches a received MAC, the message is considered authentic. So you can see that the message, this is the sender, message is uh, gone through a MAC algorithm, and the MAC with message has been sent to the receiver. The receiver receives the message and sends the message to MAC algorithm, that is key. The MAC algorithm compares the two MAC keys. If the MAC is found, then the message is authentic. The integrity is checked, else something is not right. This is how the MAC code works. Um, digital signatures. Digital signatures provide a way for the sender to prove their identity and ensure that the message has not been tampered with. Digital signatures, digital signatures provide a way for the sender to digitally sign a message using their private key. So now, just because I said digital signature, you might be thinking that's just a sign. No, guys, it's not just a sign. It's like, which, yes, of course, we have a name called digital signature, but it uses a private key. The receiver can identify the signature using the sender's public key, which validates the sender's identity and ensures the integrity of the message. The digital signatures also provide a non-repudiation, meaning the sender cannot deny sending message once it has been signed. So the thing is, the signer and verifier. There's two part. There's two persons, signer and verifier. Data has been modified into data has been implemented with hash function. Hash is sent to signature algorithm. Signer's private key has been given the signature algorithm. So the data and signature will go to the verifier. The hash function and verification algorithm will be separated. Not separated. The hash function will separate uh, the keys and compare whether they are equal or not. This in this verification algorithm, the verifier has the signer's public key. So this public key and private key will be compared, and the hash function will also be compared in order to verify the data is valid or not. This is how digital signature works. Moving on to HMAC. HMAC is a type of MAC that uses secret key and a hash function to generate a message authentication code. So hash-based message authentication code is a specific type of MAC that uses cryptographic hash functions. It's nothing but we saw We saw cryptographic hash functions, right? And this HMAC is nothing but in cryptographic hash functions, the messages can't be decrypted, whereas in HMAC, it can be decrypted. This is a combination of cryptographic hash function, the secret key to generate the message authentication code. HMAC provides a stronger security guarantees than traditional MACs by incorporating a hash function into the computation process. So basically, MAC, the message with a hash function and key has been integrated and sent to the receiver, where the receiver checks the hash output, MAC, and the key, and results will be given true or in a positive way if both matches, and results will be in a negative doesn't if they both don't match. So how it works is it receives the message along with the HMAC authentication code, recompute the HMAC for the received message using the same HMAC algorithm. Compare the computed HMAC with received HMAC. If two HMACs match, it indicates that the message has not been tampered with during a transit, it and that it originated from the sender. I'll read it again. It first receives the message with an HMAC authentication code. HMAC is nothing but an authentication code. It recomputes the HMAC for the received message using the same HMAC algorithm and the shared secret key. There will be secret key shared with the authentication code. So the HMAC will be compared and computed using the HMAC algorithm. If the the two authentication code matches, then it's not been tampered. If it doesn't match, it has been tampered, and you can directly say this message has been altered or tampered, and it's not from the sender. Authenticated encryption. Authenticated encryption algorithm provide both confidentiality, authenticity for encrypted messages by encrypting the message and authenticating its integrity at the same time. Authenticated encryption. Authenticated encryption algorithms such as AES, DES provide both confidentiality and authenticity for encrypted messages. These algorithms encrypt the message and authenticate its integrity using single cryptographic operation. We'll see how it works. I'm sorry. So encryption. The message is turned into a secret code using a special key. Authentication. A special code is generated based on the secret code to check if it hasn't been tampered with. So there's encryption, authentication, transmission, decryption, and verification. In transmission, the secret code and the special code are sent to the receiver over an insecure channel. I'll give. I don't care whether the channel is insecure or not. I have my encrypted message. The intruder has no idea what I'm encrypted with, and I have a special key. They can't. I mean, it is possible, but it's not very easy. So decryption and verification, how the receiver will decrypt messages. The receiver uses a special key to turn the secret code back into the message. Then the receiver generates a new special code, compares it to the received one. If they match, the message is considered to be authentic. If they don't match, the message is rejected, directly rejected. So, why do we need message authentication again? Data integrity, data authenticity, protection against tampering, non repudiation, secure communication, detection of replay attacks, flexible implementation, and complementary encryption. Basically, I want my message to be delivered as it is I have sent. And message authentication technologies or algorithms helps me to verify that. There is either there are two things to be verified. One, the if the message which is sent has been tampered with or not, or did the message go in time, or was it delayed? These are the basic two things that are being checked in this message authentication process. This is the basic. I need my message to be delivered properly. So I personally feel like this is one of the important topic to be discussed with, and this is the best and most intelligent innovation or in a creation in cryptography, because without this, there will be no advanced steps. So I'm very honored to talk about this topic. I'm really very honored to talk about this topic, and really thank our Professor Mr. Dr. Ganeshan sir for giving me this opportunity. And I love this moment. I love this experience. I'm thanking you, sir. Have a good day.